a limit. Okay, so this is 1, and now let's go to Roman numeral 2. This is going to be the definition of a limit with notation. Okay, so the definition of a limit with notation. So I'm going to use a certain phrase, and I'm going to use this phrase very, very often. Okay, a limit is an estimated f of x value, okay, as you approach a specified x value from the left and the right. Okay, so the limit is an estimated y value that as you approach a specified x value from the left and to the right. Sometimes it exists, and sometimes it does not. Okay, so in order to kind of help you understand this, I am going to draw a little graph here for you. Okay, so I'm going to draw a graph, and we are going to talk about the limit as we approach it from one side and as we approach it from the other. So let's sketch this graph. It's going to go like this. I will use red to kind of draw the graph. So it's going to go something like this with an open dot right here. And then we're going to have a closed dot here, and it's going to go like this. Okay, so this is our function f of x. Okay, it's a very wonky looking function. Okay, now we're also going to have some very specified values. So what we're going to do is we're going to use letters for this to make it seem like it can work for anything. So we're going to call this value right here, we're going to call this k, and we're going to put this value right here, and we're going to call this L. Notice K is in line with the open dot, and notice L is in line with the closed dot. Now, we're also going to put a x value, C, right here. Okay? So this is the function that we are going to be working with. Now, what I want to do is I want to define the notation of a limit for you. So the first thing we're going to look at is we are going to take the limit as of f of x. So this is of the function. So the limit of f of x as x approaches c. Okay? So the limit of f of x as x approaches c. So c is this x value right here. Okay? So we want to approach c from both the left and from the right. Okay? Now, there is a very specific way that we write this out. Okay? So, first of all, I'm going to show you what it looks like when we talk about approaching it from the left. So we are going to find the limit as x approaches c, and from the left, we use a little negative sign. So this is the limit as x approaches C from the left. Okay? So we're actually going to do that. We are going to take the limit as f approaches C from the left. So from the left means it's coming from the negative side. So I'm going to highlight this part in yellow. Okay? So you're going to see it on the graph as something highlighted in yellow. So I am going to approach C from the left-hand side. I'm going to keep getting closer and closer and closer to C. Now, when I get closer and closer and closer to C, I need to go up, and the limit is not the value of C. The limit is the f of x value. So when I go up this way and I get closer to C, notice that the y value is k, okay? Even though there's a hole there, it's getting closer and closer to k. So I'm going to say the limit as x approaches C. Sorry, my lights went out. So I just need to stand for a second. So the limit as x approaches C from the left is equal to k. Now, we also have to take the limit as x approaches C from the right. Notice that I am using a plus sign. Okay? So this means the limit as x approaches C from the right. So the limit as x approaches C from the right. Okay? Now, I'm going to highlight this one in pink. Okay? So take a look here. Notice that I use a plus sign. Plus sign, I think positive. Positives are always on the right side of a number line. So I'm going to approach from the right and get closer and closer and closer to C. Okay? But now, because I'm approaching from the right, I am tracing this part of the function. Okay? I am not tracing this part of the function. So when I approach C from the right and I go all the way up, okay, the value that I get is equal to L. Okay? So when I approach the function from the left, it has one value. Okay, so its limit is one value. And when I approach it from the right, its limit is another. But the key thing I need you to understand with this definition is I need you to understand that it's not the x value. It is the y value as you approach from the left and the y value as you approach from the right. Okay? So we're going to do a couple things to kind of just keep hammering this away and make sure that you are understanding how this works. So we've looked at a piecewise function. We've now defined what a limit is. Now we're going to just keep finding some limits, doing some different activities. Okay? So the first activity I would like you to do is I am going to make for you, or I'm going to set up here, and you can use a graphing calculator for this one if you wish. I would like you to graph this function, f of x equals x squared minus 4 over x minus 2. And we do need to note x cannot equal 2. Now remember, you need to remember from algebra to pre-calc, things like that, x cannot be equal to 2 here because you cannot have a 0 in the denominator. So you cannot have a 0 in the denominator. So we are going to exclude x equals 2. So what I would like you to do is I would like you to sketch a graph that goes from 0 to 6 on the x-axis. Okay? So go ahead, use your graphing calculator and plug it all in, or use Desmos and plug it in there, and then sketch a graph of the function. So pause the video and go ahead and make that sketch. Okay, welcome back. I am assuming that you have made the video or made the graph and sketched it in. So I'm going to quickly kind of sketch this graph in. I know there's a couple key spots. First of all, I know there's one at 2. It crosses the y-axis at 2. And then I also know it has like a slope of 1. So it's going to go 1, 2, 3, 4, 5. And then so we go 1, 3, 4, 5, 6, 7. So here we have our first dot here at 2. Then we go here and we just the line, and notice it should just be a straight 1, 2, 3 straight line that goes like this. And then it goes like this. But remember, we do have one sort of weird spot. So at x equals 2, I know something is going on. Okay? So here's the first thing I would like you to do. And we're going to talk about and take a look at the notation that I was just showing you. So the first thing I would like you to do is I would like you to tell me what is the limit as x approaches 2, but I'm going to use the negative sign. Okay? So the negative sign means we approach from the left. Okay? So let's take a look at this. You can pause the video, try to figure it out yourself, and then we'll kind of go through the answers. So the first one is we're going to approach it from the left. So I'm going to approach 2 from the left side. So I'm going to follow along here and get closer and closer and closer to 2 from here. So it's just like tracing this graph until I get all the way to here. And when I get right next to 2, what is that value? Well, it clearly kind of looks that the value is 4. Okay? As we go across, the f of x value is 4. Now, you also need to take a look or figure out what is the limit as x approaches 2. And if I put a positive there, the positive means from the right side. Okay? So I'm going to use pink again, and I'm going to approach 2 from the right. So I am going this way, getting closer and closer and closer to 2 from the right side. Now remember, it's the x value of 2. So I'm tracing down this graph, and right when I get close to 2, notice that it has the same value. So the limit as x approaches 2 from the right side is also equal to 4. Okay? So this is what we're doing when we find a limit. We check it from the left, we check it from the right. Now, there's a big thing you need to remember. If both the left limit and the right limit are equal, then we say the limit as x approaches 2 exists. Okay? So if you approach it from the left and if you approach it from the right, now and they are the same value,